Hello and welcome back to another video on quadric surfaces. Today we will be talking about elliptic paraboloids. In the last video I briefly introduced ellipsoids, another form of quadric surfaces. And just to remind us what a quadric surface is, essentially a quadric surface is a graph of a quadratic in three variables. Meaning what? Our strategy is to plot the intercepts, we are going to plot our traces, and then we are going to complete the picture from there. So without further ado, let's go into the general equation of what an elliptic paraboloid is. An elliptic paraboloid is plotted by the general equation z over c is equal to x squared over a squared plus y squared over b squared. So let's just go ahead and dive into an example to see how we are going to graph one of these. So first of all, the question asks us to graph z is equal to x squared over 4 plus y squared over 25. We have our three-dimensional graph right here, and we have our strategy laid out right there. First of all, we are going to find and plot the intercepts, then we are going to plot our traces, and then we are going to complete our picture. So, moving on to step 1, we are going to find and plot our intercepts. Our x-intercept is when our z and our y are equal to 0, meaning we have the new equation of x squared over 4 is equal to 0, meaning what? The only solution for this is x is equal to 0. And you may notice a trend here wherein, well, let's just do it. Our y-intercept, we are going to set our z and our x equal to 0, meaning our y squared over 25 is going to equal 0. Meaning our y is only going to be 0, that is our y-intercept, and for our z-intercept, this one's also pretty visual, easy to see. X is equal to 0, y is equal to 0, we just have z is equal to 0 now. Meaning that we have no intercepts. The only intercept on this graph is going to be 0, 0, 0, so I will just plot that right here in blue. Step 1 is completed. Now, what we are going to do is we are going to begin to plot our traces. Recall in the last video that I like to color code my traces because I think it makes it easier to visualize. So, we are today going to start off with the YZ trace. You will find out why soon. So what is the YZ trace? The YZ trace is when we do what? We essentially set our other variable x equal to 0. So now we have y squared over 25 is equal to z. That is going to give us a parabola. So we have z is equal to y squared over 25. There is nothing more to mess with that. Now, we have our xz trace. Our xz trace is essentially going to be the same concept. We have our x variable and our z variable. We are going to set our y equal to 0, meaning we have similar z is equal to x squared over 4. Well, those are two of our traces here, and for our final trace, we are going to graph the xy trace. So if we come over here, we will just go ahead and keep our x, we will keep our y, and we will make z equal to 0, but this means that we are going to have 0 is equal to x squared over 4 plus y squared over 25, meaning what? This is not going to be a traditional function. This is going to just be the point 0, 0, 0. So, something that I'm going to introduce, a concept right now, is the z is equal to z not trace. So, what this means is essentially you will have scenarios wherein one of your traces may give you 0, 0, 0, or that may give you a point instead of a function. This essentially means that you have to hold this z value as a constant rather than setting it to 0, okay? So setting z equal to z naught essentially is setting z equal to 1, z equal to 2, z equal to 3, z equal to z naught. So we are going to do that. Our z equals z naught trace is now going to be setting this right here in our equation equal to a number, some constant. So we now have z naught is equal to x squared over 4 plus y squared over 25. And I just want to make it clear now that you may recognize what this shape looks an awful lot like. This is kind of similar to a circle, right? In the xy dimension. So this is an xy plane circle. And since this z naught is not a specific number at all, that means that we are going to have multiple z equals z naught traces. So let's just go ahead and graph it, and I will explain further. So our yz trace is z is equal to y squared over 25, meaning we are only going to be drawing this in the yz. We are going to forget this right here. Yz, we are just going to make a very rough parabola. All right. Just a little parabola. Looks good. Now we are going to come over here to our xz trace. This is x squared over 4 is equal to z, meaning we are going to ignore this y-axis. So we are going to have something that looks like this. Looks good. I maybe should have made this more in the negative y and x direction, but I think the point will get across. So this z equals z naught trace, meaning what? Our z equals z naught trace is z naught is equal to x squared over 4 plus y squared over 25, meaning we are graphing in the xy plane, okay, so we don't really have to worry about this, but this is just going to be a shift upward, if you understand what I'm saying. So what I'm trying to say is that if our z naught is equal to 1, that will be this point, z naught equal to 2, that is this point, z naught is equal to 3, 4, 5. All of those points are going to be represented onto this graph. So we are going to graph x squared over 4 plus y squared over 25, and we are only going to just connect all the lines. So as you can see, a shape is actually being created here. And I'm glad my doodle looks a lot better than it did last time. So if you can visualize this, this essentially almost looks like a bowl, like a cup of some sort, wherein our z equals z naught trace is in the xy plane, our yz trace is in the xz or yz plane, and our xz trace is in the xz plane, making this our shape. So we plotted our traces, we completed our picture, and this right here is essentially what an elliptic paraboloid looks like. Just recall that our elliptic paraboloid's general equation is z over c equals x squared over a squared plus y squared over b squared. Thank you.